So now we start with the RLC circuits, but the things which contain only R, L and C, and when we apply voltage source, so except voltage source, the circuit what we have is called a passive circuit. Means they contain only components R, L and C. However, in the first year itself you are made aware about an operational amplifier in the Arduino. So an operational amplifier provides us amplification. So I would like to draw a simple circuit. So if we add amplifiers in the circuit, a circuit consists of R, L and C plus amplifiers is called an active circuit, and that active circuit allows us to have substantial kind of permutations and combinations. So two things I will add today. Number one, amplifying, and number two, adder, simple adder. So op amp you have learnt about, you might have forgotten, so I will just check what you know, extent of your knowing, and we shall proceed further. So once active circuits are done, most of the part of the subject is done at its preliminary level. Don't look at the syllabus. I am sure that you must not have looked at, except him, nobody might have asked even what is the syllabus. So this is an operational amplifier. If I apply V in here, V in T here, this is R1 and this is RF. What is VOT? What is VOT? VOT is equal to 1 plus RF upon R1 into VOT. You have forgotten? So if you have forgotten, you will revise it after the lecture so that tomorrow we can address it. But right now, tomorrow we can address it means we are continuing the lecture. Output is 1 plus RF upon R1 times VT. This is one thing. Most important thing which must be taken care of is, say we are having a circuit like this, which we have learnt about. This is input, and here we obtain output. But this output obtained is under the condition, that it should not be used. Why? Listen very carefully now. This is 1 farad, this is 1 ohm, and we find some differential equation for some I O relationship. In that, what we have done, we took Kirchhoff's law across this mesh, and we said that this IRT is equal to ICT because it's a series circuit. So what is the assumption? What is the assumption? That this current through this entirely comes here, means no current is drawn out. Clear? So output is a notional output, means you even connecting voltmeter also will change the, I will give an example. Suppose if you are having a glass container in which some water is there, and you want to make, you don't have a scale on the glass, so you have a metallic or plastic scale, and one more thing what we can have, let it not be a glass, it's a metal container, so from outside you can't see. You simply, to check what is the petrol level, you have a scale, and you dip that scale in your petrol tank. You dip that scale in petrol tank, is it okay? You dip that scale in petrol tank. So when you dip the scale in petrol tank, what happens to the level of the petrol actually? Are you getting me? The level of the petrol is, what is the purpose? Level of the petrol is to measure. By what? By dipping the scale in the tank. The moment at which we dip the scale in the tank, the level rises. So the parameter to be measured gets changed by the measuring process. You should have a 0 dimension rod, which we can't have. So whenever you connect a voltmeter will draw some negligible current. So some change will definitely be there, but we must ensure that it is negligible, right? So any circuit what we have, the output what we say is under the condition that no current is drawn out of that. No current is drawn out of that. Therefore, when we want to interconnect some circuits, at that time, since this is called as loading, an amplifier has got output. When you connect the speaker to it, it draws the current. This is called a loading effect. So as to avoid loading effect, what we must have is called a buffer. Means it is in the first year itself, you might have listened it. This is V in T and this is VOT, which is almost equal to V in T. And since operational amplifier is having very high input impedance, it draws no current. So with this, you can connect any further circuit. Means, if I have this circuit and I want to drive something from this circuit, I can connect it there. What I have to add? I have to add a buffer, and then this we output. There you can connect anything. So in most of the cases we use this buffer. Buffer we can have amplifier, and also we can have adder. Adding. So how adder we can construct? What is VO? VO is equal to V1 plus V2 minus V1 plus V2 plus V3. Then again you can amplify it by -1. Again -1 you can get it plus. Is it clear? So in general, in the previous thing, we add just 2 more blocks. One block is a amplifier or multiplier, and inside that I can put K. Means what it is? What is VOT? VOT is equal to K into, right? VOT is equal to K into V into T, where K can be any real number including 0, -1, -2, -0.5, plus 10, plus 100, -50, anything, right? Is it clear? So this is a circuit which consists of operational amplifiers. So net gain is K. Is it right? Is it okay? And then using like this, you can have an adder where there are 2 inputs. We can say V1T and V2T, and what is the output? VOT is equal to V1T plus V2T. Is it clear? So a multiplier, that is scalar, which is input is equal to K, output is equal to K times input, and adder where output is equal to addition of these 2. So these 2 blocks, scalar or multiplier and adder. So I think there is no rocket science. So with this, we can have the circuits which we can construct, increase their proportion, and we get more and more complex circuits. So what is our purpose? For every such circuit, you must be able to obtain a differential equation between V in T and VUT. Differential equation is generated if either inductor or capacitor comes in the circuit. If it's only resistive, then differential equation question doesn't arise. Is it okay? So RLC plus multiplier plus adder. So I hope that multiplier and adder are most simple real circuit realizations. These are simple building blocks with no further discussion needed on these things so as to proceed further. Is it okay? So with this now, we proceed with a very interesting circuit. Again we keep values simple. And now so same circuit, I have just added one adder and one multiplier. Here I use the gain as A, small a. One adder and one multiplier. So what is the question? Derive the differential equation between V in T and VUT. So we can pause the video, otherwise it will be just blank, and then students can see it in two parts.